It's just a small example on how to sketch a polynomial function. It's already in factored form, which is nice. Just by finding its x-intercepts, knowing a little bit about end behavior and the behavior at multiple roots. Alright, so first off, let's figure out what the degree of this polynomial is. That would be, if we multiplied it all out, what would be its highest powered x value? Well, here we'd have a single factor of x. Here we would have two factors of x. Here we would have three factors of x. So if we multiplied those together, it would be like multiplying together x, x squared, and x cubed. This would give us x to the 6th. So this is an even degree polynomial. So its end behavior is either both up, like this, or both down, like this. Now, what determines that is the sign that's sitting out front. Now, if it's positive, it would have been both up. But because it's negative, our end behavior is going to be down and down. Okay, so if I wanted to graph this, I also know the x-intercepts just by looking at this. All I would have to do is set it equal to 0 and solve for x. Well, here x is equal to 0, so we have the origin as one of our points. Here we are going to find that x is equal to positive 3, so that would give me this point here. And here we would have x is equal to negative 4, and we'd get this point here. Alright. Now we know that the graph is coming from down here because it has an end behavior going in that direction. So it's going to have to come up to these points, do something, and then end up going back down this other side. What exactly it's doing, I'm not quite sure, but let's find out. If it's just an odd, like a 1, it's just going to go through one way or another. It's not going to do anything fancy. But here at negative 4, it's got this cube on it. That means it's a triple root. And what happens at cubics, or odd powers of roots, we're going to get this leveling effect, where it does like the x cubed type graph. So it's going to come up from bottom, come in a little earlier on negative 4, go through it, and then just up. So you get this little leveling effect going through the negative 4. Eventually your graph's going to have to turn around and come back down and hit the origin here. So it's eventually going to have to come up and then eventually turn back around. Now it's not a pretty graph, but it's just going to go through the origin because it only has a power of 1. It's not going to do anything fancy. Again, we're going to have to bend back up to hit this point, but this one has a square on it. And what happens at squares is you get what looks like a parabola. But it's going to bounce off of that 3. So as we come up and hit the 3, I'm going to come in a little early again, bounce off the 3, and end up shooting down. So this green graph would be a sketch of this function g of x. This is what you get when you do it on a computer. So again, it's coming up, it levels off here at 4, it has to turn around, come back through the origin, and then as it hits, goes back towards 3, it comes in a little early, bounces off of it, and shoots down. Now compare that to my graph. Which one looks better? Well, the computer graph, but you get the general feel for what these things have to look like.